Hello friends, welcome to Sekho. In this video we are going to discuss about representing real number on the number line. So let us say you have a number 4. How will you represent this number on the number line? This is very easy. You have to first draw a number line. Okay, then you have to choose a reference point. Wherever you want, you can choose a reference point or a starting point. This is 0. This point represents 0, and then we take a unit distance like this much, and after that we cut same distance, this unit distance, on this number line, and this point represents 1, then same distance, then this point represents 2, then we cut same distance 3, we cut same distance and represents 4, we can cut same distance and the point represents 5. So on the number line we have got representation of 4. Okay, so this is the representation of 4. You mark this point and say that 4 is represented by the point P on the number line. Okay, you can elaborate this like this, what I have said. If question comes like this, that represent number 4 on the number line, so you will start like this. I draw a horizontal line and then I take a reference point O and we say that it is representing 0, then we cut unit distance and the point where this number line is cut represents 1, then we cut again same distance and this cutting point representing 2, and then finally this point P representing 4. So this is what representation of number 4. Now if a question is like represent this number 3.567, how will you represent this number? So again, if you want to represent this number on the number line, first of all you have to draw a number line. Okay, and then you have to take a reference point wherever you want. Let us take reference point in this point. O is our reference point. We call that this point O represents number 0, then we cut unit distance and this cutting point represents number 1, then we cut again unit distance and it cuts number 2, and so on. So we have to represent 3 point something. So this point is representing 3, then this point is 4. So from this decimal expansion, you are sure that it is greater than 3 and less than 4. So number must lie in between 3 and 4. So now let us assume that this scale is divided into 10 small blocks. Okay, so 1 2 3 4 5 6 7 8 9 10. You assume that there are 10 divisions between 3 and 4. So 0.5 means it will go up to 5 divisions. Okay, so it will go up to 5 division and then something. So you cannot see it properly, so zoom it. Take a magnifying glass and zoom it. If you zoom it, what you get is we zoom 3 and the portion between 3 and 4. So this is 3 and this is 4, and we have 10 1 2 3 4 5 6 7 8 9 10. So you have 10 divisions between 3 and 4. So you have to go 5 division, 1 2 3 4 5, and so 3.5, you got 3.5, but it is little bigger than 3.5. Okay, and so it will be somewhere in between. So you will go 3.5 here, and then between 3.5 and 3.6. So this is 3.1, this is 3.2, this is 3.3, then this is 3.4, this is 3.5, then this is 3.6, then this is 3.7, then this is 3.8, then this is 3.9, and this is 4. I am writing 3.1 on the above this straight line and 3.2 down the straight line, because we cannot write side by side. There is no sufficient space. There is no other reason for this. Okay, so in this case the number lies between 3.5 and 3.6. So what you will do is you will magnify this portion again. You will magnify this portion again using magnifying glass. Okay, again magnify. What will you get? You will get a line. Let me resize it. Okay, let me resize just 1 second. I will write 4000. Okay, I should not keep ratio. Okay, cancel, and then file, resize. Okay, I'll write it 4000. Okay, so okay, let me clear everything. So what we have done so far is we have actually expanded the portion between 3 and 4. The number was 3.564, I think. Okay, so we have magnified the portion between 3 and 4. Now there are say 10 divisions on 2, 3, 4, 1, 2, 3, 4. So there are 10 division on 2, 3, 4, 5, 6, 7, 8, 9, 10. So this number will be like this is 3.1, this point is 3.1, then this is 3.2, then this is 3.3, then this is 3.4, then this is 3.5, then this is 3.6, 3.7, 3.8, 3.9, and then 4. So this number lies between 3.5 and 3.6, because this is less than 3.6 and greater than 3.5. So what we will do, we will magnify this portion again, 3.5 and 3.6. So if we magnify 3.5 and 3.6, what we will get? We will get like this is 3.5 and this is 3.6. So there will be 10 divisions inside. Will be means we are doing 10 divisions. So let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions. So this is 3.6, this is 3.7, not 3.6, 3.51, this is 3.52, this is 3.53, then this is 3.54, 3.55, 3.56, 3.57, 3.58, 3.59, then 3.6. Okay, now this number is 3.56. So we'll go 3.5, 3.56, 3.56, and then we have another digit 4. So it will lie between 3.56 and 3.57. It will lie between these two numbers. So we again magnify this, and what we get? We get again, let me change the color. Okay, so I am changing the color for the purpose of refreshment. 3.56, and here we have 3.57, and we magnified this portion. So we will divide it in 10 portions, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 portions. So this point will represent 3.561. This will be 3.562. This will be 3.563. This will be 3.564. This point will 3.565. This point will be 3.566. This point will be 3.567. This point will be 3.568. This point will be 3.569. Then this will be 3.57. Okay, so this number 3.564. So this number will be represented by this point. This point. Okay, so if we zoom out again this thing, what you will get, that this was number line and this was 3 and this was 4, maybe this was 3 and 4. So it will be like you have to go middle, up to the middle between 3.4, then some slightly more than this. If we will zoom out, it will be like slightly more than 3.5. But if you zoom in and zoom in and zoom in, the point will be represented like that. And then if you zoom out and zoom out and zoom out, it will be little more than 3.5. okay, now it depends on how much accuracy you want. You have to zoom in, and or you have to draw this number line in a magnified way, so that you can represent the number in much accurate way. Okay, this is what representation of this number is. So I think you have understood how these things are done. So let us see your book. Let me see your NCERT book. Just have patience and see what is given in your book. I think this is the chapter. I should have kept it open. Okay, here you have seen that here they are doing this with some number like 2.665. so 2.6, the magnified number between 2 and 3, then they can go up to 2.6, but this number will be greater than 2.6 and less than 2.7, so they will again magnify this portion. Okay, and then then they again magnified this portion, and they now they can go like 2.26 and then 2.26, but then after 2.26 they have 5, so they have to magnify this portion again. So they have magnified that portion, and then finally they get the number there, isn't it? So this process is called process of successive magnification. Process of successive magnification. I don't know how they will give this in the exam, but this is very easy. Okay, you can just magnify, and you get the number. So that is the representation of the number. And you can do this same thing for any number. You can do this for even irrational numbers also, but irrational numbers goes up to their number of digits is infinity. So for this irrational number is yes, they are non recurring and non terminating, so they goes up to infinity. So you cannot represent accurately the numbers that are irrational numbers. Even you cannot represent these numbers, these numbers that are rational but not non-terminating. Okay, for example, this is rational number because this is recurring, but this the digit after this decimal point will go up to infinity. you will get 7 7 7 7 7 up to infinity. So you will not be accurately representing these numbers that are not terminating. So what you can do is you can actually go up to few decimal points. You can be accurate up to few decimal points when you are representing these numbers. But from this representation you can realize one thing, this thing, that any number has its unique representation on the number line, or any point on the number line represents a unique number, isn't it? So they have given these two exercise. Actually they want you to represent these two numbers on the number line, so you should do these two by yourself. This video is on already 15 minutes long, so I will stop here. Please subscribe this channel if you like this channel. I am going to cover entire syllabus. I'll not leave any single problem from your book, and I will try to answer all your doubts. If you write your doubts in the comment section, 100% I will reply you and I will give you answer. So you can comment. If you have any doubt, you can write in the comment section. So if you like these videos, please subscribe this channel, and I'll see you soon in the next video.